This is Mrs. Frazier, and I'm going to be going over pieces of your Unit 5 test review. So I'm going to start with number 1, although you can go back and check the key and look at, I'm going to start at number 2. You can go back and check the key, and you can look at the term definitions as well as the steps in calculating the mean absolute deviation. So we're going to use number 1 here to help us with number 2. So our first step in calculating mean absolute deviation is to find the mean of the data. So looking at number 2, it says below are a list of shoe sizes taken from a random 8 students at SJH. Find the mean absolute deviation. So we're going to start by finding the mean by adding all the numbers and dividing by how many there are. So I'm going to start by adding all my numbers. Okay, when I add all my numbers together, so step 1, I get 63.5. So for step 1, I get 63.5. And I'm going to divide 63.5 by 1, 2, 3, 4, 5, 6, 7, 8, because I have 8 different shoe sizes. And that gets me approximately 7.9. So my mean is 7.9. So that's step 1. Now I need to find the distance all of these numbers are from my mean. So I'm going to subtract the mean from each of these numbers. So I'm going to start by doing 12 minus 7.9, 5 minus 7.9, and so on. So I'm going to pause while I do that. So I want to say a couple of things about how I got these numbers. So these are the 8 numbers I ended up with. So I have 8 distances because I had 8 students. But like when I did 5 minus 7.9, I got negative 2.9. But remember, our distances cannot be negative. So I took away the negative sign to take my absolute value. So all of my distances are positive. Okay, so I found the deviation or the distances from the mean. So that was step 2. So now I'm going to do my step 3. I'm going to find the mean of these distances. So once again, I'm going to add all of these numbers together, and I'm going to divide all of these numbers by 8. So I'll start by doing 4.1 plus 2.9, and so on. I'm going to pause as I do that. Okay, so when I add all of those distances together, I get 18.5. And now I need to divide those by 8 to find the mean. So I'm going to take 18.5, divide by 8, and I get approximately 2.3, or 2.31 would be okay as well. So my mean absolute deviation, my final answer, is 2.31. So do you believe that the mean absolute deviation shows consistency for the data? Why or why not? So remember, mean absolute deviation, 2.31, is the distance. So it is the average distance. And in this case, yes, it shows consistency. Because there is a small distance between the data and the mean. Okay, moving on to number 3. According to the graph, approximately how many plants would grow if 500 seeds were planted? So looking at our scatter plot, what would help here is to create our trend line. So first I'm going to create a window where I can create my trend line in. So I'm going to create my 2 lines here just to create my window. And remember, we want to put our trend line somewhere down the middle of our data where it cuts our points in half about the same amount above as below. So the trend line is going to help us make a prediction for 500 seeds. Okay, so I want to know approximately how many plants would grow if 500 seeds were planted. So looking here at 500 seeds, I can think about if this data was to continue upward with my scatter plot. I'm going to follow that data up using my trend line. So here's 500. And I'm going to just put a dot right there where 500 would be on my trend line, the blue line that I drew. And I can see that that's approximately 50 plants. Okay, draw and describe a scatter plot with a positive correlation or association. So a scatter plot with a positive correlation is going to increase. Okay, it's going to increase in a linear pattern from left to right. So if I look at this from left to right, it is increasing in a linear pattern. A negative correlation or association will decrease in a linear pattern from left to right. Sorry about that. A scatter plot with a nonlinear correlation or association might look something like this. It has a pattern that is not linear. A scatter plot with no correlation might look something like this. So there is no pattern. Number 8, which relationship could be represented by the scatter plot? As the speed increases, the time increases. So I'm looking at my speed, and as it increases, my time, okay, so here's my speed at 55. My time is at like 20. But when my speed was at 30, my time was at like 55. So the speed is not increasing as the time increases. As the speed decreases, the time decreases. Well, it doesn't appear to be that my speed is decreasing. If I look from left to right, my speed appears to be increasing, so that's not correct. As the speed increases, the time decreases. This appears to be our best option because my line is decreasing, so indicating that my time is decreasing, but my speed is increasing from left to right. Okay, number 9. Below are 5 numbers that represent 5 different mean absolute deviations. Which mean absolute deviation will have the greatest spread or variability? Circle your answer. So I'm looking for my greatest spread or variability, meaning I'm looking for my greatest distance. Which one would be more spread out if I think about my mean absolute deviation? So remember, mean absolute deviation is the average distance from the mean. So the bigger the number, the bigger the spread. So 11.4 is the greatest spread. spread or variability. Number 10, which is the correct way to draw a trend line on a scatter plot? Just above the given data, just below the given data, below the trend by connecting the points that are given, or D, following the trend by drawing in through the middle with approximately as many data points above the line as below the line. So if you think about how we drew it back earlier in the test review, I created a window and then I drew it down the middle. So I want to kind of cut my data in half. If I draw above, then all my predictions will be too high. If I draw below, all my predictions will be too low. And if I just connect the points, I'm not really helping myself at all. I'm just connecting our data together. So D is my best, the best way to draw my trend. Number 11, what is the relationship between the volume of the cone and cylinder shown below? Calculate the volume for both and explain using complete sentences. So if I look at the volume formula for a cone on my formula chart, I'm going to see volume equals 1/3 area of the base times height. So remember, make yourself a note. V equals area of the base. In this case, the area of a circle. Okay? And for a cylinder, it's V equals area of the base times height. So I don't have 1/3. So everything else is the same. Okay, so I could say the cone is 1/3 of the cylinder. Let's go ahead and calculate the volume. So looking at my cone, I know I'm going to do 1/3 times the area of my base. So to find the area of my circle, I'm going to do pi radius squared times my height. So this is for my cone. So that means I'm going to do 1/3 times pi 2 squared times 8. I get approximately 33.5. Remember, we do that in units cubed or cubic units. Okay, and to find the volume of my cylinder, I know I'm doing area of the base times height. So in this case, I'm going to just do pi r squared for the area of my circle times 8. So I'm going to do pi 2 squared times 8. And I get approximately 100.5. Okay, and that would be units, and I'm just going to put a U cubed because I'm out of room. Okay, so there's my two volumes, this one for a cone and this one for a cylinder. Okay, a cone has a radius of 4.25 and a height of 12 centimeters. How much water can the cone hold? Hint, you are solving for volume because we're talking about how much can it hold. Okay, so drawing my cone, I know it has a radius of 4.25 and a height of 12. Knowing my formula, 1/3 area of the base times height. We know the base of this is a circle, so I'm going to do pi r squared for my base. So 1/3 times pi radius squared times height. I'll do 1/3 times pi times 4.25 squared times 12. And I get approximately 226.5 0.9. And this would be labeled centimeters cubed, or cubic centimeters. Okay, number 13, find the volume of the sphere. Be sure to write down your formula and plug in all your values. Keep your answer in terms of pi. So remember, terms of pi is don't multiply your pi. Okay. So my formula for a sphere is volume equals 4/3 pi radius cubed. So plugging into my formula, I'll have 4/3 times my radius cubed. And we're just going to put pi down here, but we're not going to multiply by it. So when I type into my calculator, I will only type in this piece. And I get approximately 317.8. And we know we still need to multiply pi. So my final answer is 317.8 pi centimeters cubed. Number 14. Number 14, coffee is sold in a cylindrical canister with the measurement shown below. How much coffee can the cylindrical container hold? So again, since it says hold, we're solving for volume. So volume equals area of the base times height. We know the base of my cylinder here is a circle. So pi r squared times height. So that means I'll do pi, the radius is 5 squared times 13. It doesn't say in terms of pi this time, so I'm going to type pi into my calculator. And I get approximately 1,021.02 centimeters cubed, or cubic centimeters. Okay, number 15, use the diagram to list as many pairs of congruent angles as possible. Then list as many pairs of supplementary angles that add up to 180 degrees as possible. So I'm going to start with my congruent angles. I know angle 1 and angle 4 are congruent. I know angle 5 and angle 8 are congruent. That means I know angle 1 and 5 are congruent. I know angle 4 and angle 8 are congruent. I know angle 1 and angle 8 are congruent. And I know angle 4 and angle 5 are congruent. So these are all congruent angles. But we have some more congruent angles, so switching colors. I know angle 2 and angle 3 are congruent. And I know angle 6 and angle 7 are congruent. So that means I know angle 2 and angle 6 are congruent. And angle 3 and angle 7 are congruent. And I know angle 6 and angle 3 are congruent. And angle 2 and angle 7 are congruent. Okay, so now I need to list my supplementary. So I'm going to kind of slow down. I'm going to switch colors here. And I'm going to circle angles that would be supplementary to each other. So let's start with an angle that would be supplementary to angle 1. So an angle that would be supplementary to angle 1 is angle 2. Meaning these two angles would add up to 180. I also know angle 3 would add up to angle 1. So this is all with angle 1. I also know angle 7 would go with angle 1. And angle 6 would go with angle 1. So what you're noticing is since angle 1 is an obtuse angle, all of my acute angles would go with that obtuse angle. So let me just write down some of those. Angle 1 and angle 2 are supplementary. Angle 1 and angle 3 are supplementary. Angle 1 and angle 7 are supplementary. Angle 1 and angle 6 are supplementary. And I could keep going, but I think we kind of see the idea. So these would be my supplementary angles. And I'm going to erase this so we don't get confused by that. So those are just some examples of my supplementary. Those are not all of them. Okay, number 16. Write and solve an equation that can be used to find the value of x. Okay, so I want to write my equation. So looking at this angle and this angle, I can see that these two angles are equal to each other. They're the same size. So 4x plus 10 equals 8x minus 25. Okay, I'm going to circle my x's, and I'm going to put squares around my constants to help me organize my information. So I want to solve for x. So first I want to get x on one side. So I'm going to add the opposite, 4x minus 4x, to get rid of 4x on this side. I have to keep it balanced, so I add minus 4x on the other side. So I have 10 equals 4x minus 25. Then I'm going to circle my variable, my x, and put squares around my constant. So I want to get x by itself, so I'm going to put my boxes on the left side. So I need to get rid of minus 25 by adding 25. So I'm left with 4x equals 35. And I'll divide by 4. $35 divided by 4 gets me 8.75. Okay. Next example, I can see that 5x plus 35 and 45 degrees, these two angles are not the same size, meaning they're going to add up to equal 180. So 5x plus 35 plus 45 equals 180. I'm going to circle my variable, put boxes around all my constants. So since these two constants are on the same side, 35 plus 45 is 80. So I'm going to go ahead and put those together. I'm going to circle and box again. I need to get x by itself, so I'm going to subtract 80. I'm left with 5x equals 100. And then I'm going to divide by 5. So that means x equals 20. Okay, filling in the missing measurements for each angle. If this angle is 105, that means this is 105. And this is 105, and this is 105. These are all congruent angles. I know that this angle and angle B will add up to 180. So this has to be 75, meaning this is 75, this is 75, and this is 75. Okay, if this angle is 40, I know that this angle is also 40, and this angle is 40, and this angle is 40. And if this angle is 40, then angle A must be 140 to make 180. So angle C is 140, angle F is 140, and angle E is 140.